Quasar, and welcome to Quasar Does Astronomy. It's that time of the week again, and today we'll be looking at a video by Nathan Roberts. Nathan's a flat earther who goes by Flat Earth Doctrine on YouTube. In this video, Nathan believes that he's found proof the Coriolis Effect doesn't exist. Now, Nathan, where was it you said you were again?
On a baseball field.
Well, say no more. I'll get some stuff together and join you. Come on, magic of editing.
Well, that didn't seem to work. We'll give it one more try.
Okay, that's much better. Now that I'm ready to join you on the baseball field, let's see what your proof is.
That direction that way is the east. This direction that way is the west. We got north back here. We got south that way. So I'm hitting it north.
Okay, so let's assume you're hitting the baseball due north. This should give you the highest change in latitude and the most noticeable effect.
Now, if we were truly spinning on our axis at over 1,000 miles per hour.
Okay, so let's address that real quick. You'll often hear flat earthers talking about how fast the Earth is spinning on its axis. Now, what Nathan is specifically talking about here is tangential velocity, and to be even more specific, tangential velocity at the equator. This is where that velocity is the greatest. The other type of velocity we must deal with in this kind of problem is angular velocity. Now, you may be unfamiliar with angular velocity, and that's alright. Angular velocity merely describes how fast an object is rotating. Typically, we measure this in degrees or radians per second, although, when we talk about the Earth's rotation, we will use degrees per hour.
A 15 degree per hour drift.
Thanks, Bob, for your help. As Bob said, if we assume the day to be exactly 24 hours long, then in order to turn 360 degrees, it must turn at
A 15 degree per hour drift.
Okay, Bob, less helpful the second time. Trust me, I got this. Okay, where were we again?
On a baseball field.
No, sorry, I should have been more specific, my fault. I meant, where were we in the video?
In a straight spin. Then what should happen is that the ball should land like way over that way to the west.
Okay, so here's where it seems Nathan is getting a bit confused. Let's break it down a bit and see if we can explain it better. Let's think of the Earth as a solid body that is rotating. Let me go ahead and grab the beach ball from the previous video right here. Now, we can look at this line right here, and we can, when we rotate the beach ball, we know that this line never gets out of sync with the rest of the beach ball. It always stays in the same position relative to the rest of the beach ball. So, as a solid body, all parts of the Earth rotate together, and they will rotate at the same angular velocity of 15 degrees per hour. Because of this observation, we see that different points on the Earth must be traveling at different tangential velocities. And another key point to understand here is the Earth and the atmosphere rotate together. This means that the atmosphere is also rotating at the same angular and tangential velocities as the Earth underneath it. Since the Earth is extremely large, the difference in tangential velocities as you move a few feet left or right are minute. This means that when you hit the ball up in the air, the distance the ball has traveled is not large enough to notice with the naked eye.
Let's check it out and see if the 10 and 8-year-old have to know anything about Coriolis in order to figure out how to catch a baseball.
Again, all this shows is that the effect is minimal at these short distances. Let's say you're playing wide receiver on a football team and I'm your quarterback. You run a go or a post route to the end zone. Now, being a decent quarterback, I need to lead you with the football so that you can catch it in stride. So, I throw the ball about 10 yards ahead of you, for example. As the wide receiver, you can look at the ball and get a good sense of where the ball will land, so you run over and catch it. You didn't need to do any intense calculations. Our brains are very adept at calculating parabolic motion without any real conscious thought.
And while I hit it way over his head, It did not land out of the field to the west. You know why?
Because that's what the flat Earth idea and the globe model both predict?
Because the Earth is not spinning.
Nathan, it seems like you're not hearing anything I'm saying. I just explained this.
In fact, that one had a slight spin on it this way, and it pushed the ball that way just because of the spin of the ball interacting with the air. And so it spiraled a little bit that way.
Honestly, Nathan, that's the most correct you've been all video. The spin of the baseball can have an effect on the path it takes. I can throw 5 different pitches with the same arm angle, the only change being the grip I have on the ball and the spin it comes out of my hand with, and you'll see 5 completely different pitches.
It didn't end up that way.
Nor would we expect it to.
Oh, there you go. There we go. That's another good pop-up. Straight up. And it stayed inside the baseball field.
Again, exactly what we would expect it to do.
These are simple tests, guys. You really have to be willfully ignorant to choose not to believe your God-given senses.
Nathan, I'm not telling you to throw away what your eyes see or your ears hear. All I'm saying is that our eyes can only see so well, and our ears can only hear so well. I have very good vision currently. However, when I get older, that won't be the case. And when that happens, I'll go to an eye doctor and get glasses based on the prescription that I'm given. I'm sure everyone knows someone who has some form of corrective lens for their eyes. Those lenses are tools that we can use to see better. This is no different than tools and instruments that scientists use. Our eyes, as good as they may be, were not designed to take precise measurements. If you were building a home, I'm sure you'd use a tape measure, because eyeballing 5'10" 3/4 inches on a 2x4 is quite difficult. I'm sure after a few trips to the hardware store to pick up new lumber, you'd move over a few aisles and get a tape measure.
The Earth is stationary and flat. There's a dome over our head. The Bible testifies to that. Your reality testifies to that.
Nathan, your interpretation of the Bible testifies to that, but not mine.
Is just as ridiculous. See up here? They're setting up a carnival up here. These machines, you know, they'll go around and stuff. It's just as ridiculous to get on one of those machines and say, yeah, I'm not spinning. Yep, not happening. Complete asinine assessment. You know you're spinning.
I actually found a very good video that discusses the Coriolis Effect from a channel called What the Physics. For those interested, the link to the video will be in the description below. I urge you to check out that video for some real-life examples of the Coriolis Effect. So far, I've not done my own video specifically on the Coriolis Effect. However, you can keep an eye on my Wednesday series to see when I do. Well, this is where I will go ahead and end the video. Hopefully Nathan and everyone else here learned a thing or two about why we don't expect baseballs to fly off to the east or west every time we throw or hit them. If you'd like to see more of this content, please give a like and subscribe. And if you have any suggestions or questions you'd like answered, please leave them in the comments. I'm Quasar, and this has been Quasar Does Astronomy. Keep learning!